Hello again. Thank you for watching. Let's wrap up this assignment. That means we do 79 and 86 out of the Red Books Chapter 5. And to be perfectly honest, I made a slight mistake when I assigned number 79. I misread the problem. I thought it was more complicated than it is. Number 79 says a car moves 65 kilometers due east. That's vector A. Vector A is equal to 65 kilometers east. That makes it a vector. And then we have, then the same car goes 45 kilometers due west. So our second vector, which we're going to call B, is equal to 45 kilometers due west. This is a truly simple problem. I thought it read one direction was side to side, east or west, and the other direction was north or south. I thought we were going to add things that weren't lined up. The total displacement, which we would call, which is our resultant, which is what we would like, that is what we're trying to find. This one is super easy. All right, little compass rose off to the side to remind ourselves of which way is which. Never eat sour watermelon or shredded wheat or soggy waffles or whatever you want. Okay, first we go east by 65 kilometers, and these are just sketches because I did not require this on graph paper. So that is 65 kilometers off to the right. And then we're going to come back, and I'm not going to draw it right on top of it. We come back 45 kilometers, which better be shorter, which is heading towards the west. Our resultant vector goes from the beginning to the end, so it is purely this little guy here. When they're lined up, we get to add or subtract. In this case, it's going to be subtraction because it's heading in the other direction. So R, well, the true statement of what R is always equal to vector A plus vector B, which in this particular case, our magnitude of R is equal to the 65 kilometers that's going towards the east, which we'll call positive. 65 kilometers plus this second vector, which is going in the negative direction, so I'm going to say plus a negative 45 kilometers. I prefer that instead of just saying minus 45. So we end up with a displacement with a magnitude of 20 kilometers, and it is pointing to the right because the one going to the east was greater. So 20 kilometers east, and that was easy. Okay. Now for number 86, this one will be a little tougher. Back to values that are similar to what we had before. Just to get a quick snapshot of it, we have 128 newtons going to the left, we have 64 newtons going to the right, and we have 128 newtons going at 30 degrees above the positive x-axis. Okay, so those are going to be our three variables. I'm just going to list them out. I'm going to say that my first variable, the first vector that I listed, I'm just going to call it A, is equal to 128 newtons in the negative y direction. Vector B is equal to negative y, it went sideways, it was negative x direction. And I'm just going to put that in parentheses here. The next one is 64 newtons long, and it's going in the positive x direction. And then we had a third vector, which we'll just call C, which is 128 newtons at 30.0 degrees above the positive x-axis. Okay, so let's make a quick table here. We'll be dealing with vectors A, B, C, and they'll be adding up to give us R. And we will separately look at the x direction. We're going to find their components, and we'll look at the y direction. And I'm going to make a note up here. Well, it's just newtons. That's short enough to write in. So we'll deal with that. All right. A is really easy. It is all in the x direction, but it is in the negative x direction, so we're calling the value of it negative 128 newtons. 0 of it is in the y direction. Likewise for B, it is not up and down. It was straight to the right, so that is a positive 64 newtons. C is at an angle, so that means we have to resolve it into its component vectors, or break it into its component vectors. Remember, C was something like this, so what we're finding is C sub x and C sub y. This guy here was C. So the x component of vector C is equal to the length of vector C, the 128, multiplied by either sine or cosine. The angle they gave was right here. The x-axis is the adjacent side, so ka toa, so cosine has the adjacent side in it. I hear that in the ka sound. So C multiplied by the cosine of the angle that's associated with vector C. All right, lots of C's in there. Now, the magnitude of vector C was 128 newtons, multiplied by the cosine of the angle there, which was 30.0 degrees. So, and I'm just going to put it into my table instead of writing it down off to the side. Again, with these pink calculators, you kind of go in reverse. 30 is the value going into my cosine function, and then I can multiply that by 128. So we get 110.9 for my x-axis, 110.9 newtons, and that is in the positive x direction, so it's going to be positive. The y component, C sub y, is going to be equal to C multiplied by the sine of the angle associated with C. So that's going to be 128 newtons multiplied by the sine. Again, if you're not sure why it was sine, so Katoa says that sine is the opposite side over the hypotenuse. We are trying to find the opposite side, so we're taking the hypotenuse and multiplying by that sine function that relates the two of them. 128 newtons multiplied by the sine of 30 degrees. Okay, calculator. 30 sine times 128 is 64. Nice even 64. 64 newtons, and it was definitely up, so that's positive. So at my resultant over here in the x-axis, 128 being negative, plus 64, plus 110.9, 46.9 newtons. And my y-axis, well, that one's easy, 64 newtons. Now that I have the components of my vector, I know that in the x direction, I'm coming off to the side a little bit. We're saying that this is here. This is r sub x, and r sub y is a bit bigger than r sub x was, so I'm going to cross off that part and say it started there. And this is my r sub y, and so r is off in this direction somewhere, and this will be the angle that we find for r. Okay, so the magnitude of r, is going to be the square root of r sub x squared plus r sub y squared. So that is the square root of 46.9 newtons getting squared plus 64 newtons also getting squared, and square root the whole thing so that r ends up being equal 46.9 squared plus 64 squared equals, and then square root, and we get 79 point. Actually, we only had 2 sig figs on this problem, so we got to call that 79 newtons. And then for the angle associated with R is the inverse tangent of the opposite side of our angle, which is R sub y, divided by the adjacent side of our angle, R sub x. So that is the inverse tangent of 64 newtons, R sub y, divided by 46.9 newtons, R sub x. And so my calculator spits out 64 divided by 46.9 equals, and then inverse tangent 54 degrees. All right, so our final answer for R is that vector R is equal to 79 newtons found at an angle of 54 degrees above the positive x-axis. And that's our final answer. Now, before I shut this down, I want to go back and double check, because we should be checking our angles. This angle, 54 degrees, is, and based on the vague sketch I made where R sub y was a bit bigger than R sub x, looks to be in the right neighborhood. It is definitely a bit more than 45 degrees. And back on number 5, this angle here, now remember this was a vague sketch. I could believe the small angle of 13 degrees. My sketch makes it look a bit bigger, but at least it's in the right ballpark as far as the size of the angle goes. All right. So you should make a general examination of those things. There is our final answer. Thank you for watching with me. I hope you enjoyed learning with me today. I enjoyed learning with you.